students. Welcome to my YouTube channel. I am here with a series of lectures in order to give you solutions of term end exam December question paper 2023. So let's start with question number 4a. Find T S belongs to Z such that T times 105 plus S times 40 equals GCD of 105 and 40. Applying Euclidean algorithm to find GCD. 105 is equal to 40 into 2 plus 25. 40 is equal to 25 into 1 plus 15. 25 is equal to 15 into 1 plus 10. 15 is equal to 10 into 1 plus 5. 10 is equal to 5 into 1 plus 0. Since the remainder becomes 0, 5 is the required GCD. Now apply the following process to find S and T. 5 is equal to 15 minus 10 is equal to 25 minus 10 minus 10 is equal to 25 minus 2 into 10 is equal to 25 minus 2 into 25 minus 15 is equal to minus 1 into 25 plus 2 into 40 minus 25 is equal to minus 3 into 105 minus 40 into 2 plus 2 into 40 is equal to minus 3 times 105 plus 8 times 40. Thus we find that S is equal to 8 and T is equal to minus 3. Now we move on next question. Question number 4b. Given is that H and K are normal abelian subgroups of a group G and H intersection K is equal to E. Let H1, H2 belongs to H and K1, K2 belongs to K, then H1, H2, K1, K2 will belong to HK. Then consider H1 K1 into H2 K2 into H1 K1 inverse into H2 K2 inverse. If we show that this is in H intersection K, then H1 K1 into H2 K2 is equal to H2 K2 into H1 K1. That is, HK will be abelian. Now, H1 K1 into H2 K2 into H1 K1 inverse into H2 K2 inverse is equal to H1 K1 into H2 K2 into K1 inverse H1 inverse into K2 inverse H2 inverse. By rearranging we can show that this whole quantity belongs to subgroup H. Further in the same way we can rearrange H1 K1 into H2 K2 into H1 K1 inverse into H2 K2 is equal to H1 K1 into H2 K2 into K1 inverse H1 inverse into K2 inverse H2 inverse, such that the whole quantity is in subgroup K. Hence HK is abelian. Further, if H intersection K is not equal to E, then HK will not be abelian. Moving to the next problem. 4c. In each of the following cases check whether or not S is a subring of R. First one is S is equal to A divided by 2 to the power R such that a comma R belongs to Z. Use the fact that if S is a non-empty subset of a ring R, then for each A, B belongs to S. If A minus B also belongs to S, then S is a subring of R. Let S1, S2 belongs to S such that S1 is equal to A, 1 by 2 to the power R1, S2 is equal to A, 2 by 2 to the power R2. Then S1 minus S2 is equal to A, 1 by 2 to the power R1 minus A, 2 by 2 to the power R2. Hence, By rearranging the terms, it is shown that S1 minus S2 also is in subring S, and S is a subring of R. The second part of this question is S is equal to a 2 cross 2 matrix over real number. Take two elements S1 and S2 from S and show that whether S1 minus S2 is contained in subring S or not. Here we found that S1 minus S2 does not belongs to ring S is equal to M2R. Therefore S is not a subring of M2R. Thanks for watching.